Hello, my name is Faiz Shafiq, and today we would like to present our series hybrid three-wheeler project. So first thing first, the question, based on the question, our vehicle should have the following design criteria. First, it should have 50 km in range. It should be able to carry two occupants. It should be running on 0% gradient, and it should have series hybrid configuration. So what are our design approach? First, we build an electric vehicle that can meet the 50 km requirement. So this is 100% relying on electric. Then we add an engine to increase the vehicle range by 50%. So the total autonomous range should be 50 km from the electric and 25 km from the engine, and that equates us around 75 km in total range. Before we start designing, we should have a design concept. So we took an example from Thailand, an electric tuk-tuk conversion project. So we use the parameter there, such as your rolling resistance, your aerodynamic coefficient, and your um, frontal area, and all the necessary stuff lah, to calculate our load for this project. What we have here is our steady state road load calculation. So what we have highlighted here is the average speed and the top speed. The average speed being 35 km an hour and the top speed being 70 km an hour. And what is the most important here is the peak value. The peak value is what we use for our motor selection. And we have calculated here, taking into account the inefficiency and the use of gear ratio, which is equal to 5. We have chosen this motor, and there will be two quantities of motor attached to the two back wheels. And why did we choose this motor? Because it fits all the requirement. The first requirement is the peak torque. If we use two motors, we could get 61 Newton meter of torque, whereas the requirement is only 46. The second requirement is the peak power. It is able to produce 24.2 kilowatt of power, whereas the requirement is only 17, and the top speed of 3,800 RPM, whereas the requirement is only 3,715, and of course the average torque required at the average speed. And battery sizing. So the objective of this sizing is that it should be able to get us 50 km in range. So taking into account the specification for lithium ion and the road load, we have identified that the battery configuration should be 20 in series and 20 in parallel. As for the engine sizing, the objective here is to increase the vehicle range by 25 km, which is around 50% of the total range. So 50% of the total road load is somewhere around 4.47 kilowatt, and that equates to 4.47 kVA. And we have identified the suitable engine to be used in our project on the right here, which is a Tokai 11 liter 224cc.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohammad Zafarki, and today I'll be proposing the 3D model of the vehicle. So as you can see in the diagram, there are two tires at the back and one tire at the front, and also on the two tires at the back there will be two motors on each wheel at the back, spinning the tires. And also the concept of this design is through the rickshaw that was proposed in the first few slides. That's it from me. Thank you.
Simulation for the design we made. So here you can see our engine block and our battery block. So first we are gonna run our simulation. So when we start, you can see our battery capacity is at 1 and distance was at 0, and now as this distance is increasing, battery capacity is decreasing, we have already uploaded the drive cycle we made here. And you can also notice that the fuel usage is 0. So when the simulation stops, our distance is at around 50 kilometer and our battery capacity is 0. So from this we can know that from the battery pack we designed for our hybrid vehicle, it can travel up to 50 kilometers. So now we are gonna do the simulation for with the engine also. So first we are gonna set the thermostat controls. So our switch on point is at 0.9 and switch off point is at 0.1. So we apply this, go back, and we set the time up to 8000. Then we run the simulation again. Now also you can see that as distance is increasing, the battery capacity is decreasing. As you can see, battery capacity reaches 0 when distance reaches around 50 kilometers and fuel consumption starts increasing. And the simulation stops at 75 kilometers with a fuel consumption of 11 liters. From this we figure that our model gives an extra 25 kilometer range when we use the engine. So that's all for the simulation. Thank you.